Ladies and gentlemen, welcome back to the Security Expo podcast. And today we are talking about the future of CCTV and artificial intelligence. Joining me on the podcast, I have Vlado Damjanovski of Optic Security Group and Vidi Labs. We have Aaron Terry from Vixels Proprietary Limited, and I am your host, John Bigelow from Security Solutions Media. Gentlemen, welcome to the podcast.
Thank you. Thank you, John.
Thank you, John.
So, I know this is a really broad question when we're talking about the future of artificial intelligence and its role in CCTV or its impact on CCTV. And I say that, and I've said this to death over the last couple of months. You know, if we'd had this conversation probably 2 years ago, both of you would have been able to give me a reasonably accurate prediction of what the future of CCTV might look like in the security industry 3 to 4 years from now. I believe we're now in the realm of somewhat educated guesses rather than predictions. And Aaron, maybe you can kick us off, because I know that we've had discussions about this before, but you know, how fast is AI growing, and where do you see its biggest impacts in CCTV?
Yeah, sure. Thanks, John. Growing enormously and quickly. We've only got to look around now and see a lot of the camera manufacturers, they're building AI models into the cameras. We've still got the manufacturers that have the more centralized based analytics at the core for the larger projects, but it really is taking off to a large degree with the camera manufacturers and edge analytics. And I think, you know, the models that we've had in the past have been quite simple models. Now we're looking at models that are built into the cameras that are coming from lots of third-party developers, I guess, where they're getting models, they're putting them on the cameras. There's this sort of ecosystem of a wealth of things that you can do at the edge to collect effectively this physical space data and make use of it. And you know, our uptake, even in the last 3 to 4 months, I'm seeing large projects around the world where instead of sort of talking about ones and threes and the simple people count that we were talking about a couple of years ago, we're sort of seeing pixel changes. We're now seeing, you know, tens of thousands of cameras that are working on city surveillance projects to help gather that physical space data and blend it with other data sets as well within people count, you know, slip and fall, crowd massing in an area, people running, crowd running, you know, behavioural stuff. And I know, John, we've talked in the past a lot about the change of just a trigger for an action, and now we start looking at this whole behavioural analytics where we're looking at movement and trends of things that were stagnant or stationary, and now they're moving quickly, like scene changes and things like that. That's where we're really hitting very, very quickly. And back to your question, we're just seeing camera manufacturers and analytics companies now really driving a lot of that to market.
Yeah. So Vlado, I'm going to throw to you here, because we've had numerous conversations over the years about the potential for this sort of stuff, and it really started with behavioural analytics back in the probably early 2000s to 2010, out of a lot of the research that was being done in Reading University and some of these places, where what they were doing back then, though, to my understanding, and you correct me if I'm wrong because you're the expert on this, not me, they were really just looking at changes in pixels. Okay, this pixel's black, now it's changed to white. If that's happened, then what? And so we were looking at the potential from a behavioural analysis point of view of, can we use video to predict what was going to happen? And in the old model, where it was just literally changes in colour pixels on screen, that was probably a little bit unrealistic. But now, is that a far more realistic scenario?
Yeah, well, look...
And why has it changed?
Why has it changed? Actually, this is exactly the point I start explaining to non-technical people. Why are we now at that level where AI can be a credible tool for us in the industry? And that goes back with the actual development of both computers and software. This is included in my book, by the way, so I'm not giving a plug for the book, but just letting you know.
From pixels to light?
From pixels to intelligent, from light to intelligent pixels.
Well, there you go.
Sorry, yeah.
Available on the ASIAL website for anyone who's listening.
Correct. Now, AI as coin phrase or acronym is known since 1950s. Basically, when first computers came out, mathematicians, philosophers, physical researchers, they all thought of then at that time, one day there will be artificial intelligence. So AI is known since then. However, the development only of the personal computers, internet, faster processors, then you've got the software, brought somewhere, it is in my finding, about 2010. I think Stanford University is one of them, where students were actually developing and designing little robots to fight against each other, and who develops better toy, which is controlling and seeing the opponent, that's the winning one. So suddenly they started becoming better and better in terms of achieving through camera analysis. Processors were fast enough to do that. And then we are getting to a very important year in my mind for us to understand why this is now useful. 2015 roughly is the time when AI analytical or analytics that uses AI processing the video frames, which are 25, 30 a second, got to a stage that has got less error rate in detecting object than humans. Roughly, there is a statistic that says human accuracy of recognizing an object in a picture is down to about 5% of what the size of the pixels are relative to the whole screen.
Yep.
Now, it was found that a good analytics can do that in a flash of a second, less than 5%. So in other words, not only you can have more accurate recognition by an algorithm through the camera than human, but it is fast and immediate. So this is the breaking, let's say, year, 2015. So now we've got like Aaron said is we are now having where everybody's including that in their cameras.
Yep.
And a lot of them are more or less common objects that have been already prepared by the internet.
Yep.
Workers on the internet, students, dark net or whatever you call it, which they use algorithms. So everybody has that human recognition, vehicle, bicycle, truck, bus, but what after that?
Is this what we're doing every time we're clicking on one of those image capture things? Are we helping to train AI to recognise what's what?
It's a good
Sorry,
question.
we're divesting.
No. But it's important. That's an important question because it needs to clarify that whatever the cameras or algorithm do in recognition, they have to be pre-trained for that.
Yep.
For the training to be done proper, you need thousands of images of that object. Could be a cat, different angles of view, different distance, different poses. This is a cat, this is a cat. So a human has to train and infer this into the algorithm. Once that is done, what happens is, and you know you're publishing magazines, right? You've got bitmap, which is an image, and then you've got vector. Vector, AutoCAD, whatever. So vector takes much less space. So kind of bitmap of an image of a face of a cat is vectorized in a way so it's shrink in a way that you can have a very small algorithm that explains how the cat looks like, put it in the camera, and if the camera can read that, camera can decide very quickly because algorithm is very small. You don't have to load in bitmaps of thousands of cats now. It has been already trained through that algorithm, and the algorithm comes up and says, this is a cat, 0.92. What is that 0.92? Confidence rate, I think this is 90% certain that it's a cat. So this quick thing is because the processing power is great, but the algorithm has already done previously.
Yep.
So now the question is, how many objects can you train to be included in certain system? For CCTV, humans, vehicles, number plates, numbers, we don't need kangaroos. But I had customers asking, can we recognize kangaroo because it jumps on a track and I want to detect it? So now we need to tell them, how does AI work and that we need to train it? And that's the thing we are getting to now.
Yeah, because I was going to say, Aaron, I'll jump to you here because you were instrumental in some of the earlier facial recognition stuff here in Australia in training the algorithms. But it seems to me, to your point, Vlado, that we're moving beyond that now, where we don't need to train the algorithms anymore. With the development of specific artificial intelligence, what we're able to do is put edge analytics in cameras where it can watch, for example, a crowd outside a stadium and learn this is what a normal crowd behaviour looks like, and then determine this is what artificial, or this is what I suppose abnormal crowd behaviour looks like. Is that where we're heading with this?
Yeah, it's definitely where we're heading, and it kind of starts sounding more scarier, right? Like, it's what's the limit of this? How far can it go? And where does it stop? And I think we still like we've made the point about processing being easier now, or lighter. Well, sorry, it's more cost effective to be able to process this type of stuff. You still need a fair degree of processing. There's still that balance between when you're looking at the stadium, as you described it, some of the limitations that might come in might be, we are looking at 1,000 faces, not just one face coming down a corridor. So the computer's getting more easier. Their algorithms are self-learning, becoming a little bit more intelligent in that sense, but there's still some considerations and limitations, because the one thing we just don't want to start doing is start dropping any form of accuracy, whether it's because the compute's not there to give the high degree of accuracy and you're starting to miss things, or not compute them properly so that you're not getting the accurate data through. Because the more and more we rely on this as a tool, the more we rely on it being accurate, because again, in its rawness, it can be way more accurate than a human. But again, if the human's tired or hungover or not performing properly, the computer can do the same, right? The camera can do the same if it's overloaded with too much. There's a lot of considerations around that as well. But yeah, generally, I like now that a lot of the systems are sort of going. I think a really good scenario is the forklift, right? And forklifts can look a little bit different. So you can have something that says, "Hey, we've trained this object on a forklift," but the forklift could be quite different. Have you trained it on this type of forklift, right? So now the systems, you can sort of start to go, "Hey, I've seen a forklift. Draw the forklift in my environment, in my warehouse. Now start learning again, self-learning again, what my forklift looks like, so we can improve the accuracy." So it's really important that accuracy, as we start relying on these tools, the accuracy, the systems are trained to stay accurate and not be overloaded, and give us the data that we need to have that good decision making, or get those real-time alerts, or not miss those real-time alerts. And the forklift, if something happens, something falls or something in a warehouse, we still might want to know in real time that. So we've got to rely on these things. They've got to be accurate. We can't just throw. We can't just sort of. Everyone wants everything. I mean, you talked about the kangaroo, and that's a great example. It's kind of like you go into some of the camera manufacturers' things, and you don't necessarily see kangaroo, but you could have an airport or some sort of facility out in the remote, and you might want to know the difference between a kangaroo and a human trying to break in over a fence line, or a risk with a vehicle going past, for instance. So
I think if I may add, sorry, Aaron, I don't want to jump in, but just this is the perfect time. The most important thing is, that I mentioned earlier, it is the accuracy of recognition of an object that is better than human. That's one thing. So it's not 100%, but it's better, and it is quicker. So where this helps a lot, big systems especially, where you've got operators watching 60, 100 screens, there is no way they can pick up something there that is of critical Once you flash an alarm because there is a kangaroo or people getting into fight, that is the important thing for us, because that's much quicker than somebody scanning 2,000 cameras and trying to find that event. Now, as Aaron said, it's constant upgrading. So I always would like to say the AI can never be 100%. It can be 99% maybe, but it's enough to bring it above, let's say even above 80 to my attention. If I am the operator, I can see it, and then I make a decision. Yes, these guys are getting into fight. I better send the rangers or the police. Or no, these are old friends hugging each other because they haven't seen for, 10 years or whatever. So it always has to be seen, not replacing humans. That's the important thing, I guess, for our industry to understand. We are not removing humans. Humans are the final decision factor, but we make it easier and quicker to bring to their attention a potentially dangerous situation. And just one last thing I want to say. This is a different time of technology in CCTV than what was, like you mentioned, 20 years ago, we had video motion detection. Like you mentioned, pixel density, luminance level difference. That was so badly affecting the CCTV because everybody thought we can only pick up and extend the recording when somebody crosses the fence or whatever, and we catch the person. But then they were picking up trees swaying in the wind. They were picking up monitors flashing in, and suddenly they just completely disregard that alarm. It's like an alarm. Ignore it. It's not accurate. It's not what I want. Now they can really have a helping hand if they know what can be offered by that, but still not expecting 100%. If they are realistic and they say, look, for me it's enough to bring my attention. If it says 0.9 or 90% accuracy, I'm pretty confident that is correct, but I want to see and make sure this is really what I need to consider.
Okay, I guess the big question for me though is that up until now we've been using CCTV to, as you both alluded to, detect objects. So we might determine that that's a person, or that that's a person crossing a line, or that that's a bag that's been left in an area, or a picture that's been removed from an area. It would seem to me that the big change, and where we're seeing AI potentially play a bigger role here, is we're moving out of object detection into behavioural detection.
Okay.
So now, all of a sudden I might have John Bigelow walking out of a shopping centre, and I know as a normal pattern of human behaviour, people typically walk from the doors of the shopping centre to their car. If I'm driving a red Mazda, I might accidentally pick a red Mazda that's not mine and go to that and go, oh, that's not my car, and move to my car. So there might be one deviation in normal behaviour. But if I see someone zigzagging through cars in a car park on the camera, this to me is where AI comes in, because the AI looks at that and goes, that's not
unusual.
normal behaviour. It's
unusual.
learning to pick behaviour. Is that...
Yep, 100%. But Vlado, I think you hit the nail on the head. It's still, whilst it's bringing a change of a scene or a change of a behaviour to our attention, and it's like needle in a haystack, right? You could have thousands of cameras. What do we need to look at right at this instant, because it could be a problem? But a human being still needs to make that final decision. And I think the car park scenario is good. You might have lost your car, so you might not be doing anything wrong. So we need to understand the technology is there to help us. It's helping us make quicker decisions, especially in what we do in our industry. It's like keep people safe, right? We're ultimately keeping people safe. Protecting people is the primary purpose of what we do with CCTV.
Yeah, I agree, fully agree.
And what we don't want to do is get it wrong and falsely accuse people or make assumptions that what they're doing, because the system told us that it's doing it, is wrong, because it could be completely misleading, right? The car scenario, they might have just lost their car, right? You talked about a hug. So in our world, it's quite difficult at the moment, and I'm sure this will start to change a little bit, to tell the difference between a hug and potentially a fight, right? The system, you've taught the system, or the system's learning about two people coming together, all excited. I mean, as a human, you're looking at that on the screen, you may actually sort of struggle in the first instance to sort of understand whether that is a fight or it's a hug. Are the people happy, or are they, some people are pretty excited, right? Yeah. And so making sure that we always have a human making that final decision, but we're helping the humans make that decision a lot quicker, more accurately up front. Facial recognition is the really interesting point, right? And you've got potentially security guards or temporary staff that are coming in to help secure a facility. The facial recognition can be highly accurate compared to what a human can actually. Now, the leading facial recognition systems, unbelievably accurate, especially if it's in a controlled environment. We were talking about it earlier today on one of the stands about, we were sharing a few travel stories, and the airports now, I left Abu Dhabi sort of 3 weeks ago, and you literally walk up to put your bag in, and once it's got your initial details, it's just totally automated. It sees your face and it spits the bag tag out. Like, there's not one point after you do that initial arrive at the airport and check in that you actually have an interaction with a human directly. Hand your passport over, you're going through all these e-gates, you're going on the plane, you're hopping on the plane without even sort of checking the idea. So everyone's relying on now the system being highly accurate. But behind the scenes, you have got people making sure that everything's going right.
Yeah.
You're in controlled environment. So there's that real limitation of assuming that everything is 100% right when it might not be. We're automating, we're making things happen quicker, especially with real-time alerts when it comes to people's safety. We're making sure that we get that super quickly so we can do something about it.
Yeah.
But a human has to be ultimately making that final decision, because computers can still get it wrong.
Yeah, and just to add to that, something that goes back to your first question, can AI predict? I don't think it can predict. However, it can warn you of unusual activity, which is like that zigzag you mentioned.
Analyse rather than predict.
Analyse is a great way.
But it is nice to know that some of the algorithms are reasonably clever by detecting what is unusual. I mean, typical example would be, car are always passing and going that direction because there's the road, and suddenly a car that goes in the reverse direction, the algorithm knows this is not normal, and it raises an alarm. Maybe that's just simply somebody needs to reverse, dropped out of the truck or whatever, but certainly it can immediately raise the attention to the operator. But what I wanted to say more to it as part of the human thing, because this is a new technology that we learn, I had to study and learn, like probably you as well, and we are learning something and trying to understand better, because we've got a couple of different industries there: programming, image processing, computers, cameras, not to mention my specialty, pixel densities. You need good camera, video, image for good analytics.
Yep.
If your camera is bad or not enough resolution, not enough illumination, or is dark, you can't expect the same quality with that camera than the one that is perfectly set up to recognize whatever needs to be recognized. So once the people start learning this, then we are getting to a next stage, which I think is very important. We talking to the customer and explaining that this is not a silver bullet to solve all their problems without them understanding how that works. Once the customer understand how that works, they are then cooperative, because this is how that works. So what are your burning issues? What are your problems that we may be able to help? And this is then creating new opportunities for programmers, camera people, intelligence, software developers. Say, okay, this is required in this, because with this they can save, I don't know, $1 million, or they can save lives, or they can do whatever. So now we need feedback from the real users of it, because if we can't tell them what is that we have, they wouldn't know. If there is a businessman having 300 cattle on a ranch, and he doesn't read or learn AI, but you tell him, look, if we get you an AI, we can not only count what cattle you've got, we can classify them where they are, we can give you a warning if they're going out of this, and suddenly they say, can you do this as well? And then you add those things to the development. And I think this will be the perfect, let's say, opportunity for us to learn from real applications, rather than just selling a camera with, object detection.
Yeah.
But you need to do something with it.
All right, so I'm going to challenge both of you thinking on a point here. You've both alluded to the fact that, right now it can do X, but there will always need to be a human in the mix. And I can't recite the exact details, but there have been numerous experiments to this effect where for those people who aren't familiar, there's a thing called the Turing test that was developed by Alan Turing back in the 1950s, which basically was designed to have a computer trick someone, and both of you jump in and correct me if I'm wrong, but a computer that could effectively trick someone into believing that they were talking to a human, not a computer. And a lot of the AIs that we have now have passed that Turing test, which people thought wouldn't be possible for many years.
Correct.
What we have now is we have situations where we've got large language models where, let's take, for example, a child psychologist. We can load every child psychology textbook in the history of humankind that we have recorded into this model, and they've done this, and they've tested it, and it's actually more effective at child psychology than a child psychologist, because it can come up with the right responses to all the situations at the right time. So my challenge to both of you is, are we really going to have humans involved in the equation all the time? Because a lot of AI experts say within the next 20 years, there will be very few jobs that AI can't do better than people. Maybe you can, Vlado, if you want to kick it off.
I'm fully aware of the Turing test, and you're right. Some of these examples, if it quacks like a duck, if it walks like a duck, and it's a duck, that's kind of simplified version of Turing test. And we have gotten to that point. But don't forget, like large language models, like ChatGPT, whatever, they are still only predictors of what the sentence should be finished with, or the paragraph. They still make mistakes because nothing is perfect in terms of exactly like produced by a human. So I think we are now having a problem by judging if some of these things are being misused or abused. Like there is a lot of effort in the universities where students are passing exams to make sure that they haven't just used LLM to respond. They have to know. Plus, another copyright thing is there, that LLM uses whatever available on the internet. They literally have the whole internet words loaded in with not necessarily giving credit to where this comes from. And that is a big no-no in the academic community. So I think I will treat that with a little bit of reservation in terms of how accurate it is. It is possible to have number of doctors, for example, to train the model, and their professional opinion being narrowed down to what really they have experienced, and suddenly this LLM condenses their knowledge. It's the same like in the imaging industry, X-rays, breast cancer or prostate cancer, whatever. Now you can train the AI or the model using those examples by thousands of doctors that have gone through it and say, this is a cancer, this is not a cancer. So suddenly the knowledge of all these specialists is concentrated in an area where the AI will much quicker than them select out of thousands of images taken in a hospital to the ones that he thinks it's like 92% certain it is a cancer, but that still will go to actual real specialists to make sure there is no error, because it could be just simply a blemish on the X-ray because of some piece of that fell in the X-ray machine. So I think we are not at that stage. This is my opinion and my personal opinion. We are not at that stage where we can totally rely on AI. But the opportunities are great if we know how that works. And one of these examples that we illustrated was that we really have to now, using the AI, approach the industry and find the most effective way to improve their either production, save lives, save them money, by making them aware nothing is 100%, but we can prove that you can improve your efficiency by having these steps, using these analytics.
Well, Aaron, I'll throw it to you because to continue Vlado's analogy, if we have a CCTV system in a hospital that's being used, or a camera system in a hospital that's being used to look at, say, skin tumours, right? And it says with 92% certainty, yes, I believe that this tumour on John's back is cancerous. I'm going to send it to a doctor. If that model has looked at 748 million tumours and it said with 92% accuracy or 98% accuracy that one's cancerous, and the doctor I'm sending it to confirm it has looked at 50 tumours or 500 tumours, which one should I be relying on?
Second opinion, I think. If that's
that's a good point. Sure.
No, it's a valid point for sure. And it's the mix of humans aren't perfect either in that respect, as you point out. Machines can be human, but it's important to know that the machines have been trained by humans, right? And it just opens up a whole area of bias as well in that discussion. And the hospital's not necessarily a good example of that. But creating bias in some of the training models and the model sets that we work with creates a whole new area of discussion around that as well. Because again, train the model could potentially have some bias. The doctor in this scenario could have some bias.
Yep.
Where do you stop? What I would say, just going back to the previous point though, is I think that potentially, what does it look like in 20 years' time? Yes, our CCTV world could be so super smart that we may not need humans. Who knows? But one big consideration with what we are doing as an industry at the moment around this, you've only got to look at like what's coming out with the EU Act and on AI
GDPR,
and all the the Googles and all the big companies that are working towards this common thing, and everything that we're doing has to be used in a controlled manner, right?
Yeah.
So I'm all for this computer vision, looking for helping with tumours and skin cancers and all that sort of stuff. I think where we come to with surveillance and CCTV is avoiding this mass surveillance, right?
Yep.
So I'm very pro our technology helping exceptionally good use cases like self-excluded gamblers we've talked about last year, John. And there's a stand opposite us right now that specialises in that, because somebody has given consent and they are using this technology, and it's going to work better than humans because it is in a controlled environment where people come in and they've said, hey, I need some help. I've got a self-excluded, I've got a gambling addiction, and I might self-harm or something, and please stop me. And it is an addiction, right? And I think these use cases that we need to focus our technology on are for good, and we don't want to end up where we've got the supercomputer or supercomputers in our industry that are doing mass surveillance, because why do we need a lot of this data pulled in? What are we using it for? Is it proportionate? Is it being used for good, or is it where's the line on it becoming marketing activities, and we're doing physical space data analysis on tracking people that so I think that our industry's going to probably fall more in line. Well, it will, from a privacy perspective and a law perspective between all the countries, fall in line with the bigger and the broader AI challenges that we have. And you have a computer that can detect a skin cancer, but at the moment, you don't get up and you go and sit in front of the computer and it actually fixes the skin cancer for you. And that could happen as well. Obviously, but at the moment there's still a lot of human. It's not going to replace jobs ultimately, and I think from our industry and our perspective, I do a lot of facial recognition. We're heavily promoting it being done ethically and responsibly for really important use cases for safety and minimising harm, and you do not want this stuff going wild in our industry and becoming mainstream to a point where it's mass surveillance. It's pretty critical, because the computers will take over that, and then humans will make poor decisions on the back of it.
Well, I guess the question then, and I'll start with you, Vlado. Aaron was talking about, the inherent biases that can occur in some of these models when we have to train them. And we've already seen this with, encoded bias in things like facial recognition, where the early models weren't so great at detecting Asian faces, or weren't so great at detecting female faces, because the data sets that the scientists were working with were disproportionately, we should say, Caucasian males. And so that's what the systems were trained on. And you touched on this before we started this podcast, that's in the context of specific artificial intelligence. As we get closer and closer to artificial general intelligence, I envision, not that I'm the guru on this, but I envision that these models will start to train themselves. So where are the opportunities in this? And I'll get you to talk a bit about the opportunities, and then Terry, I'll come back to you and get you to talk a little bit about how we approach this ethically. But where do you see the opportunities moving forward for this new sort of wave of AI in CCTV?
That's an interesting question, and I have thought about that for a long time. And one thing that I can tell you, and I was a little bit involved in doing some inference teaching, just to see how that goes. Most of the object detection and classification intelligences in cameras, in servers, in software is based on something that is readily available. Typically people, students, programmers, whatever, they would get whatever is available on the internet, YouTube, pictures from their mobile phones or whatever. So the next step for CCTV, in my view, is, and this is something we've discussed it with Ollie when we started thinking and talking about digital standards, long before 62676 current standard came out. One of them would be to have the actual existing cameras to be able to piggyback on them and get footage and videos extracted from them to be used for training, because it is different accuracy and training when you do the actual camera that sees from the position where the CCTV camera is, than you taking a mobile phone and walking around. You know, there's different perspective, there's different distances. So if our industry can agree on some kind of standards, I would like to have some kind of standard agreement where government will approve or endorse collecting images of public CCTV for, let's say, learning purposes only, and this could be just completely NDA'd and they go nowhere, but actually just to teach the algorithms, where the particular views from the cameras of different angles, of different situations will be more realistic and will increase the actual efficiency of detecting things. Now, the second thing that I think might be important to note, and as Aaron said, I never would like to see CCTV as intrusion of privacy.
Yeah.
And in fact, I think we spoke about that maybe in the past conversation we had, but there are already algorithms, there are already software solutions where you immediately, automatically blurry the images and faces of people in real life view in a control center.
Well, we're seeing that in aged care homes and other places like
so
that.
Great example.
you can actually say, look, no privacy is being broken here. We only record in case somebody slips and falls, or if there is, God forbid, some kind of incident. Then you need to have judge or police to authorize playback of that footage of that happened. Then you can see who was the person that broke the window, or I don't know what. So the thing is, the intelligence or the development is in such a level you can protect all that privacy so people can feel at peace. It's really for their protection rather than for spying on them.
Yeah.
If it is positioned in such a way, it is possible for people to really benefit from CCTV in a different way, rather than, Big Brother is watching me, I don't want them to see where I'm going, whatever. If you are not doing anything wrong, if you are not an intruder, if you're not somebody that will bash somebody in the middle of the street, you don't have to worry about anything because your privacy is protected.
Yeah.
But if you try and attack somebody and you've got a knife in your hand, then we can actually recognize your face and we can find you in that way. Hopefully that will minimize future actions like that. So I think I will see it more from the perspective of protecting us, our citizens, our places, rather than intruding them. And of course that can be regulated.
Aaron, I'm mindful of the time that I'm mindful of the fact that we're coming up to the end of our time, but to continue on from Vlado's thoughts, I mean, we see a lot of opportunity for AI and CCTV. The question is, building on what you've said earlier, how do we do this ethically?
100%. Yeah. There's like no doubt, like there's changes coming here in Australia. There's obviously changes coming to the Privacy Act. We're hoping to see that in the next couple of months. We're all desperately looking for not control mechanisms on what we can and can't do. We're looking for guidelines around what is right and what is wrong. At the moment, we're seeing, in my mind, way too much ad hoc. We can do this, we can do that, and back to the camera manufacturers. And this is not a criticism on any of them by any stretch, but we need to make sure that everything is proportionate, right? If it's reasonably necessary, we can use it. And there's incredibly good use cases. The aged care one we're just talking about, I mean, our elderly people that are lying in bed, and at the moment, a lot of places may not have the ability to know that they've fallen out of bed.
Yeah.
So what we want to do is we want to know that our loved ones, if they're falling out of bed, they can get help straight away, right? But we don't want a camera that's just staring at them, that somebody might come in as a visitor and see on the back of the monitor in the office as they walk past, and they're seeing them getting changed or something. So the real balance between the reasonably necessary or the responsible use of this technology to help us is paramount. And until we get that guidance or we get the law changes, we need to take our own responsibility here and do it the right way, right? And know that, firstly, we're using it for the purpose that we need to use it for and not multiple things, i.e., why don't we just count how many people are coming in unnecessarily and, gee, we could get some marketing information out of that and just bolting on these things, right? Let's use it for, let's create good out of this and a positive public kind of attitude towards knowing that we can walk down George Street at night time and feel comfortable that there's cameras on us for our protection in case some bad person comes and hurts us. But those same cameras are not gathering anything around our personal identities and all the things that might have a flow-on effect to, identity theft and all the other things that can happen as a flow-on thing. So we need to be cautious in our approach, but not scared of using the technology for helping what we are ultimately as not just technologists but security experts coming to try and achieve a result where people are safer. But we need to make sure by design that no one needs to have any illusion that cyber protection is paramount to our daily lives. This is outside of CCTV. We're using our phones for our banking and our internet for just about every single thing, right? So we need to, as technology experts in our industry, make sure that the same approach to everything that's happening around cybersecurity is absolute paramount with what we're doing with CCTV, because the more we're doing with analytics and the more data we are collecting, the more it needs to be protected because it's more vulnerable.
So we want the public CCTV system to know that I'm going down George Street at 2 a.m, but not necessarily register that I'm drunk, dressed as a fairy, riding a unicycle.
Yeah. Totally. Is that something, John, that you're worried about?
Well, I'm just saying. I'm just putting it out there. Not that that's ever happened. Yeah. Gentlemen, thank you very much for joining me on the podcast. It's been a great discussion.
Thank you, John.
Thank you, gentlemen.
Enjoyable.
Thanks.
Thank you.
Cheers.
Bye-bye.
All the best.